NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again, after months of spouting gibberish.
A spacecraft built nearly 50 years ago, thought to be silent forever, has been restored from more than 15 billion miles away. This fragile probe, smaller than a car and powered by a nuclear battery, is still alive after half a century. Against every prediction, it sent back data that shattered old models of the solar system's boundary. Instead of a smooth frontier, Voyager revealed invisible walls and strange wrinkles in space, a chaotic edge no one imagined. If a machine this old can survive the impossible, what hidden truths might it uncover in the darkness ahead? Voyager 1 did not simply stop working in late 2022, it began sending streams of meaningless numbers that no scientist could decode. The machine was alive, but its brain, called the Flight Data Subsystem, was broken. This tiny computer, smaller than a fingernail in memory capacity, was built in the 1970s to organize information before sending it back to Earth. Decades of cosmic radiation had finally pierced its circuits and scrambled its memory. What should have been a clear report of magnetic fields and plasma waves became noise without structure. Engineers knew that if this system stayed corrupted, the mission would fall silent forever. The challenge was terrifying. Voyager 1 was more than 15 billion miles away, with every signal taking 22 hours to arrive and another 22 to return. No one could simply press a reset button. The engineers at NASA's Jet Propulsion Laboratory had to treat the probe as a patient in deep space, operating through whispers of binary code. They searched through old manuals, many yellowed with age, and pieced together maps of memory locations last studied in the 1970s. Most of the original designers had retired or passed away, so the team was working with fragments of knowledge and the weight of history on their shoulders. Each command had to be rewritten line by line. There was no room for shortcuts because even a single mistake could kill the probe instantly. Imagine trying to rebuild the brain of a patient while your hands were tied and your instructions had to travel billions of miles before taking effect. For weeks, the engineers tested patches, sent code, and waited almost 2 days to see if anything worked. The silence that followed each attempt was unbearable. Finally, in April 2024, after months of patient effort, the team received a clean signal. The chaotic stream of numbers was gone, replaced by structured data once again. Voyager 1 had accepted its new memory instructions and started speaking in a language that scientists could read. It was a moment of triumph, not only for the mission, but also for human persistence. A spacecraft designed for 5 years of work had survived the unfathomable with nothing but the determination of a small group of people on Earth. The feat has been compared to performing brain surgery on a patient who is not only unconscious, but also 15 billion miles away. The success proved that distance is not always the end of control, and that even the oldest technology can be pushed beyond its limits with creativity and patience. The world had witnessed the most distant repair ever attempted in space. But if Voyager could come back from the edge of silence, what allowed it to travel so far in the first place? Voyager's path through the solar system was not a simple stroke of luck. It was the result of a rare cosmic alignment that happens only once every 176 years. This extraordinary window opened in the late 1970s, when the outer planets lined up in such a way that a spacecraft could use their gravity to slingshot itself from one world to the next. Without this chance, a probe would have needed far more fuel, more time, and more money than NASA could provide. The 176-year alignment was not just convenient, it was the only reason Voyager could be launched at all. The idea was simple but powerful. By flying close to a massive planet, a spacecraft can borrow some of its gravity to change direction and speed up without burning fuel. This technique, called gravitational assist, allowed Voyager to hop from Jupiter to Saturn, then Uranus, and finally Neptune. Each encounter bent its path and gave it a boost, like pushing a swing at just the right moment to make it soar higher. Thanks to this natural trick, Voyager could complete a tour of the giant planets in just over a decade, something impossible with ordinary rockets. In 1977, NASA acted quickly because it knew the chance would not come again for generations. Voyager 2 was launched on August 20th, followed by Voyager 1 on September 5th. Despite the numbering, Voyager 1 traveled faster and soon overtook its twin. The missions were designed with a modest goal: to explore Jupiter and Saturn, then send back photos and data for a few years. Yet from the start, the engineers dreamed bigger. They quietly designed the spacecraft to last longer, tough enough to survive if the mission stretched into deep space. That foresight turned out to be prophetic. Voyager's design was minimalist by today's standards, yet ingenious for its time. It carried no artificial intelligence, no advanced processors, and no solar panels. Instead, it relied on radioisotope thermoelectric generators, nuclear batteries that converted heat from decaying plutonium into electricity. These provided a slow but steady trickle of power, enough to run instruments and transmit signals long after sunlight was too weak. While modern phones hold gigabytes of memory, Voyager's flight computer had less than 70 kilobytes, barely enough for a short email. Its cameras and sensors were modest, but together they created the most ambitious planetary exploration mission ever attempted. Even the shape of the spacecraft reflected its mission. The large white dish, a high-gain antenna, dominated the structure, built to send whispers of information across billions of miles. The instruments were clustered on a boom to avoid interference, and a golden record was fixed to its side, a message from humanity to whoever might one day find it. The design was not flashy, but it was resilient, and it carried everything needed for a journey that would stretch far beyond its original deadline. Voyager's launch was the product of vision, timing, and daring. The engineers knew the alignment of 1977 would never return in their lifetimes, so they seized the moment with confidence. The mission was not only a race against time, but also a declaration that humanity could use the forces of nature themselves to cross vast distances. It was an act of ambition wrapped in simplicity, proof that even limited technology could achieve the impossible when paired with cosmic opportunity. Yet the real test of that opportunity came when Voyager reached the giant planets themselves. Each encounter revealed surprises that no telescope had ever seen and no model had ever predicted. So what did this small spacecraft uncover when it looked into the storms and shadows of Jupiter? Voyager's encounters with the giant planets were not routine flybys, but moments that completely rewrote the way humanity understood its neighbors. Each world revealed secrets that no telescope on Earth had ever imagined, and each discovery was more shocking than the last. The first great surprise came at Jupiter in 1979. The planet's sheer size was already known, but Voyager uncovered something terrifying and beautiful at once. It found radiation belts so intense that any unprotected spacecraft would be destroyed in hours. Storms the size of Earth swirled in its atmosphere, and lightning cracked through clouds with unimaginable power. Yet the most dramatic revelation was not the planet itself, but its moon, Io. Scientists had expected a cold, dead rock. Instead, Voyager showed a surface alive with volcanoes, spewing fountains of lava hundreds of miles high. This was the first time active volcanoes had ever been seen beyond Earth, and it transformed Io into one of the most extraordinary objects in the solar system. 2 years later, in 1980 and 1981, Voyager reached Saturn. For centuries, Saturn had been defined by its rings, but Voyager revealed that these rings were not smooth bands, but complex structures shaped by hidden moons. It discovered braids, gaps, and waves across the rings, as if they were alive and constantly reshaping themselves. Even more stunning was Titan, Saturn's largest moon. Through its thick orange haze, Voyager detected an atmosphere full of organic chemicals, reminding scientists of what Earth might have been like billions of years ago. Titan became a place of wonder, raising questions about the chemistry that could give birth to life. The journey continued to Uranus in 1986. Voyager 2 remains the only spacecraft to have visited this planet, and what it found shocked everyone. Uranus did not rotate upright like most planets, but lay on its side, spinning like a rolling ball. Its magnetic field was twisted and tilted in ways that defied every model. Voyager discovered 10 new moons and faint dark rings circling the planet. What looked calm from a distance was, up close, a system that broke the rules of planetary science. In 1989, Voyager 2 completed its grand tour at Neptune, a frozen blue giant at the edge of the solar system. Here, it recorded winds moving faster than the speed of sound, storms larger than Earth, and an atmosphere more violent than anyone had predicted. The probe also passed Triton, Neptune's largest moon, and made one of the most haunting discoveries of the mission. Triton's surface was covered in frozen nitrogen, but Voyager watched as geysers erupted, shooting plumes into the thin air. The ice refroze before touching the ground, creating landscapes that looked young and strangely alive. With every stop, Voyager shattered human expectations. These worlds were not quiet spheres of gas and ice, but dynamic, dangerous, and endlessly surprising. The mission had already gone far beyond its original purpose, yet what lay ahead promised to be even stranger. If the planets themselves could break every rule, what would the true edge of the solar system look like? The edge of our solar system was never a simple line, and Voyager proved that in the most dramatic way. For decades, scientists imagined the heliosphere as a smooth bubble blown by the solar wind, a neat boundary where the influence of the sun would fade and interstellar space would begin. Models described it as round and balanced, but reality turned out to be far stranger. When Voyager 1 crossed this invisible border in 2012, it found not silence but turbulence. Plasma density spiked, magnetic fields twisted, and streams of charged particles vanished. The spacecraft had slipped beyond the sun's protective shell, and the boundary was nothing like the models had promised. Voyager 2 made its own exit 6 years later, in 2018, but its data did not match what Voyager 1 had seen. Instead of compact walls of energy, Voyager 2 recorded a long river of particles flowing far into the interstellar medium. The two spacecraft, launched only weeks apart, crossed the heliopause in different directions and revealed two completely different structures. One seemed like a wall, the other like a stream. This contradiction shook researchers because it meant the solar system's frontier was not stable or uniform. Instead, it was flexible and shifting, like an ocean surface hit by storms. Even more surprising was the heat. Instruments on Voyager 2 showed that the plasma beyond the solar system was much hotter than expected, nearly 30,000 degrees Celsius. But because it was so thin, the spacecraft did not feel heat in the normal sense. It was more like moving through a faint fog that carried enormous energy yet remained invisible. This discovery forced scientists to rethink how energy moves between stars, suggesting that the space beyond the Sun is far more dynamic than anyone had believed. Both Voyagers also reported that the heliosphere's edge was not smooth. It was folded and wrinkled with vast ridges and valleys created by the constant push and pull of solar storms. Waves of energy from the Sun traveled outward and warped the bubble, sometimes chasing the probes as if the boundary itself was alive. Instead of crossing into a calm emptiness, the spacecraft was moving through a frontier that growled and shifted with every solar eruption. What should have been a border turned out to be a restless zone of chaos. The message was clear. The Sun's influence does not end neatly at a single point, but stretches and folds across billions of miles, shaping a frontier that changes with time. For humanity, this meant that the edge of the solar system was not a barrier, but a stormy threshold into the galaxy. The neat textbook drawings were gone, replaced by the image of a living shield constantly reshaped by cosmic winds. If the very border of our home system can be so chaotic and unpredictable, then what lies deeper in the space beyond, where no sunlight reaches and no model has yet dared to predict? Even after crossing into interstellar space, the Voyagers did not fall silent. Instead, they began sending back whispers of information that carried clues about the space between the stars. These signals were faint and rare, but they were enough to keep the spacecraft alive in the minds of scientists. Voyager 2 still has a working plasma instrument, and this single tool has become a treasure. By measuring the temperature, density, and speed of charged particles, it offers a direct look at the conditions outside the Sun's influence. The data revealed that the interstellar medium is not empty, but filled with a thin gas shaped by both distant stars and solar storms. Each reading acts like a weather report for a region that no human eye can ever see. For the first time, scientists could track the flow of matter between stars, learning how energy and particles move through the galaxy. Voyager 1, though older and damaged, still contributes vital information. It no longer has a functioning plasma instrument, but it measures magnetic fields with precision and listens to plasma waves that hum across space. These waves are not sound in the traditional sense, but vibrations in charged gas, like ripples in an invisible ocean. When Voyager detects these waves, it is as if the spacecraft is hearing the deep voice of the cosmos. Each vibration helps scientists estimate the density of the plasma around the craft, even without direct measurements. What makes this pair so powerful is the fact that they are in different locations. Voyager 1 is further out, more than 15 billion miles from Earth, while Voyager 2 follows a slightly different path. Together they provide two sets of eyes in the dark, showing that interstellar space is not the same everywhere. Sometimes Voyager 1 detects a change in magnetic pressure that Voyager 2 does not, and other times Voyager 2 records shifts in plasma that Voyager 1 misses. These mismatches prove that the galaxy is not uniform, but a place of constant variation and turbulence. The faint signals also remind humanity of how fragile these probes are. Each message takes more than 22 hours to reach Earth, and the power that carries it is less than that of a light bulb. Yet across billions of miles, the signals still arrive, carrying scientific gold. To scientists, every line of data is not just a number, but a story about the frontier beyond the sun. The Voyagers are more than machines. They are ears pressed against the dark, recording the hidden weather of the galaxy. The question is not whether they will keep sending signals forever, because the nuclear batteries are fading. The real question is what final secrets they might reveal before the silence comes. And when that silence falls, what will humanity choose to remember most? The data, the distance, or the message carried on the golden record? Long before the Voyagers crossed the edge of the solar system, their creators gave them a gift that was not meant for science but for meaning. Attached to each spacecraft is a 12-inch disc of gold-plated copper, a record designed to carry the story of Earth into the unknown. It is called the Golden Record, and it is both an archive and a message, a time capsule launched into eternity. The idea came from astronomer Carl Sagan and his team, who wanted to send more than machines into space. They wanted to send a greeting, a memory, a symbol of what it means to be human. With only a few months to prepare, they collected sounds, images, and music that could describe our planet to anyone who might one day find the record. It was an impossible challenge. How do you capture an entire world on a single disc? Yet they tried, and what they created remains one of the most daring cultural projects in history. The Golden Record includes greetings in 55 languages, from ancient Sumerian to modern English. It carries the sound of a heartbeat, the laughter of children, and the roar of waves crashing on a shore. It holds pictures of animals, plants, cities, and mathematical diagrams that explain the structure of DNA. Music from across cultures fills the grooves, from Bach and Beethoven to traditional songs from Peru, China, and Senegal. The record is less a scientific instrument and more a poem, a declaration that Earth is alive and full of voices worth remembering. On the cover of the disc, engineers engraved instructions on how to play it. These include diagrams of the hydrogen atom, the universal constant of time, and a map of pulsars pointing the way back to our galaxy. Even if the discoverers are nothing like us, the symbols were chosen to be universal, written in the language of physics and mathematics. In this way, the record was not a message for humans, but for anyone or anything capable of thinking. The truth is that the chance of another civilization ever finding the Golden Record is almost zero. The Voyagers are tiny against the vastness of space, and they may drift for millions of years without ever passing near another world. But the point was never the likelihood of discovery. The point was what it meant for humanity to send it. In the middle of the Cold War, when nations were divided and fear was constant, the Golden Record was a reminder that Earth could still speak with one voice. It was less about aliens and more about us, a mirror showing that we chose to define ourselves by music, kindness, and curiosity. Today, the records remain bolted to the sides of the spacecraft, protected only by thin metal and the freezing silence of interstellar space. They may never be seen again, yet they will almost certainly outlive Earth itself. Long after our cities crumble and our oceans change, those disks will continue to float, carrying the sound of rain and the words "hello" in dozens of languages. The Golden Record is humanity's most fragile monument, and yet it may also be its most enduring. If you were given the chance to send a message like this, what would you choose to include? And what story would you want strangers, perhaps light years away, to know about us? Every machine has a limit, and the Voyagers are no exception. Their hearts are 3 radioisotope thermoelectric generators, nuclear batteries that have been fading slowly since the day of launch in 1977. Each year, the power output drops a little more, and engineers are forced to make painful choices about which instruments to keep alive and which to shut down forever. The countdown has already begun, and by the 2030s, silence will come. These generators work by turning the heat from decaying plutonium into electricity. At the beginning, the Voyagers produced about 470 watts of power, enough to run cameras, spectrometers, and communication systems. Today, that power has dropped to less than half, barely enough to keep the most basic instruments running. NASA has already switched off several devices, including the cameras that once showed us the moons of Jupiter and Saturn. Each shutdown feels like closing the eyes of the spacecraft one by one. Engineers have learned to stretch every last watt. They have rerouted power, adjusted heaters, and even allowed parts of the spacecraft to operate in temperatures lower than they were ever designed for. The fact that the Voyagers continue to function is not only a tribute to the technology of the 1970s, but also to the determination of the people who still monitor them today. Many of the original designers are gone, yet a new generation of scientists has taken up the task of keeping these aging travelers awake for just a little longer. Still, the numbers are clear. By the middle of the next decade, the batteries will not produce enough energy to power even the simplest sensor. The transmitters will fade, and the voices of the Voyagers will vanish into silence. When that day arrives, humanity will lose its farthest messengers, 2 probes that have traveled more than 15 billion miles into interstellar space. Yet even in silence, the story will not end. Without power, the Voyagers will continue to drift for millions, perhaps billions of years. They will circle the galaxy as tiny relics of a civilization that once looked outward. Their golden records will remain attached, carrying the heartbeat of Earth, the sound of rain, and the greetings of our species. Long after every city has vanished and every coastline has changed, those fragile disks may still be floating through the stars. The end of power is not the end of the journey. It is simply the moment when the Voyagers must travel alone, beyond the reach of their makers. And that raises a haunting question. When the last signal finally fades, what legacy will these distant machines leave behind for us to remember? Voyager's journey shows us that the solar system is not a closed room, but a doorway into a much larger and stranger reality. What began as a 5-year mission turned into humanity's longest adventure, proving that curiosity can push fragile machines beyond every limit. The probes remind us that the real frontier is not just space itself, but the human drive to explore. Even when the path leads into silence, the universe has no final wall, only endless questions waiting to be asked. So what do you think? What secrets still lie beyond, waiting for us to uncover? Share your thoughts below, and if you want more stories like this, make sure to like, subscribe, and join the journey with us.